We're going to start by going through and just talking about all the different products, what they're used for, their application, and some of the tools. So we'll start by talking about what this is. This is called a gang box. This holds an outlet or a switch. This is also considered a new work box. New work meaning you're framing up a new basement or the drywall hasn't been installed yet. The reason that is because you can put it up against your stud and then you can nail these screws into the stud to keep it in place. It has these little dimples that'll kind of help you gauge how far out from the stud it should stick, because that'll allow the drywall to be flush with it when it's complete. This is another example of a single gang box, again for a single outlet or a single switch. This is a deeper box, so if you have a lot of wires, you might need a deeper box, but they come in different depths for different application purposes. But this is also considered a old work box. Old work meaning that the drywall is already installed. So you cut a hole in the drywall, you slip this in. As you're tightening these screws, these wings stick out, and what they'll do is hold against the back of the drywall and allow it to be secure in any place you want. Sometimes you also use these in new work whenever you don't have a stud or you want to put an outlet in a location that's not right up against the stud. Another example of a single gang work box is a metal. The metal is used because it's more rigid. You can really anchor this strong to a stud if you're using it indoors. One warning though is you have to knock these knockouts out and then use an additional fastener whenever you're putting your wires in order to keep your wires firm inside the box. You can also use these if you're using conduit or other applications. That's kind of beyond the scope of this video. This is called an extender. What this allows you to do is basically extend your gang box out. So if you install your gang box and then you put your drywall and you realize that you have a gap between the drywall, you can add this on, which will then allow the gang box to be flush with the drywall. Another useful example for this is if you have no tile backsplash and you want to add a tile backsplash to your kitchen, let's say, all of a sudden now your tile is sticking out farther than your gang box is. You can add this to the gang box, which then pulls out your switch and your outlet to be equal with your tile. So that's what that's used for. This is a circle, and this is used for ceilings more often than not for lights. This is also considered a old work box because it has the wings that pop out as you tighten it. You can also use these above a sink or if you're installing sconces. So you kind of have to plan what your light is going to require whenever you're installing your boxes, because you want to get a box that matches what your light is. Here's another example of a circle that has these additional supports. You'll normally see this in a ceiling where there's a heavier light or a ceiling fan, because these supports will pull out and you can screw these into your studs to give that extra support for a ceiling fan, limit wobbling, etc. All right, so we have our wire nuts. They come in all different colors, which coordinate to what wire you're using. So we have two different types of switches here that we'll go over. So this switch has 3 screws in it for when you have one switch for all of your lights. This one has 4 screws in it when you have 2 switches to work all of your lights. We have staples. Staples are required whenever you're doing any new work to keep your wire in place. Code says different things, normally within 12 inches of any of your gang boxes. This is a test lamp that you can buy when you're testing out wiring, but we're also going to use it to demonstrate today. Tools, you have your Phillips. Sometimes it's nice when you're doing electrical work to have one that's insulated. You have your flathead common screwdriver, your cutters. These are also used for twisting wire together. Your strippers for stripping the insulation off of wiring. And your cut knife or far as wiring goes, wiring comes in different gauges, which then coordinates with color. So the wire we have here is white, which is a 14, a 14-2 to be exact. The reason it's 2 is because there's 2 wires coming out without the ground. Another example of 14 would be 14-3, which has 3 wires coming out without the ground. What's the difference between the two? You would use the 14-3 when you're trying to wire 2 switches to 1 light, where you need an extra wire, which we can talk about in another video. But in today's application, 14-2 is all we'll need, which is the 2 wires in the ground. So what we have here is a quick demonstration of a light that will be controlled by a switch. Right now there's no switch present. So what we have is our source of power coming in from our breaker, going into our single gang box, which will in the future hold our switch, coming out the bottom, and then going over to our light box with our test light hooked up. So as you see, you have black connected to black all the way through, and then you have white connected to white all the way back. So what that is allowing it to do is have a circuit of power. So in essence, your positive power is flowing through the black into the light, and then returning on the white, back to the white, back to the breaker. So that whole connection allows that light to turn on. So let's demonstrate. Power, light turns on. Kill the power, light turns off. Pretty straightforward, right? So what we want to do now is show how do you introduce the switch to this equation. So first, let's demonstrate breaking of the circuit. So the breaking of the circuit is taking these 2 wires and separating them. Now when we turn the power on, what will happen? The light doesn't turn on anymore. So that's because we broke the circuit. And that's how electricity works. If you don't have a circuit all the way there and back, the light's not going to turn on. So now how do we connect this circuit and close the circuit using a switch? So what we have here on the screws on the side is 1 gold one and 1 non-gold one. So something easy to remember is that your power, your source, always goes to the gold. And so if you trace the line coming from the box, that's going to be this wire here. So what we want to do is align that wire with the bottom of the bottom screw, and then we're going to put our load on the top screw. So it's as simple as putting it into the wire holder. What I like to do before I even do that is I like to screw these screws tight. Now some people like to use these screws and wrap the wire around the screw. That's up to you. But for ease of use of this demonstration, we're going to go ahead and just slide on the back, give it a pull, make sure it's tight. Do the same thing to the other one. Flip it over, and then what you want to do is add your ground. So once you've added your ground, you're ready to test this out. Give me 1 second. Now I never suggest people leaving wires out like this, but for this demonstration I'm going to show you what we did. So I turned my power on. The light's still not on because the circuit is not closed. So that's all a switch does, right? Is it closes your circuit. So now I've turned my switch on. So inside the switch, you have your power coming in down here, and you have your load up here. And then when you flip that switch, it's actually flipping a bar to make those 2 touch. And in essence, turning the light on, closing your circuit. That's how a switch works. What you want to do is grab your knife. Give yourself about 3 inches to work with. Use your knife to lightly score the insulation material. The other option a lot of people do is cut the insulation along the length of the wire, like that. The reason for that is, if you do cut the wire, it's going to be the part of the wire that you're removing the insulation on anyways. And you can pull that off. Go ahead, discard that. Same thing with your paper. And exposes the paper. Okay, so now black, white, ground. So you want to get a pair of your strippers. Might be very difficult to see, but on these strippers there's different numbers. Those numbers tell you what gauge wire to go into that hole. So this is 14.2, which means it's 14 gauge wire. So go ahead and locate your 14, slide it in there, give it a twist. What that does is it severs the insulation, and then you can quickly pull the insulation off, just like that. Same thing on the other side. If you want to get real fast and don't care about throwing that on the floor, you can go ahead and do that. So that's how you go ahead and strip your wires. I like to grab this, wrap it around one time. Makes like a nice little hook there. You can put that around your ground. On the other side, you can do the same thing, or what you can do is use these openings in the back and just pop your wire in. Make sure it's secure. Same thing with the other one. Make sure it's secure. What I like to do is I like to take my electrical tape and run it around, covering up these screws. This is something I like to do because when I'm putting this in to the gang box or taking it out, you can see that I would be closing the circuit with my hand, and what that would do is cause it to be shocked. Same thing with an outlet. If I was pushing that in or taking it out of outlet and I touch both screws with one hand, I would shock myself. So that's just a little tip. So to release this wire, you grab your small screwdriver. There's a little slot right above the wire or below the wire. Stick the screwdriver in at the same time pulling out the wire. Same thing with the other one. Stick the screwdriver in and it immediately releases the wire. Justin here from Weekend Warriors. I hope you liked the video. If you liked it, go ahead and like our channel, subscribe, and hit me up with a comment on what you would like to see next in a video. Thanks everyone.